Hey everybody, Mr. Quick here. Welcome to Eureka Math / Engage New York Math, Module 5, Lesson 19, Surface Area and Volume in the Real World. Let's take a look at a few examples of when we would find surface area and when we would find volume. And then the real world part will come in very soon. But remembering, the surface area, if I have a box, a surface area, let's draw the box here. Kind of does that little line on its own, but if I have a box that's a three-dimensional shape, the surface area would be all six sides of the box. The front, the side, the other side, and the back would also be the top and the bottom. But it's only covering that. So think about it, if you were going to put wrapping paper on this box, you would only cover the outside. That's surface area. Volume is going to be what goes inside the box. So if I was going to fill this box up with a particular item, whatever I fill the box with, that's volume. Okay, so let's look at a couple of examples here, a little Venn diagram action about when you would find each one. Okay, so on this side we have volume. On this side we have surface area. What they have in common is that they're both a way to measure space figures. They measure space. Volume measures space inside, and it's only the space that's needed to fill the inside. So if you have a cup, volume would be how much liquid the cup could hold. All right? It's measured in cubic units. Surface area measures the outside surface. So if you have that same cup, volume is what is inside the cup, how much liquid or whatever you would fill up the cup. Surface area would be if you had like a koozie and you're going to put on your cup, maybe like a Jayhawk koozie or something, then that would cover the outside, right? It would cover the faces, so to speak. Okay, it includes all the faces of any three-dimensional shape, is measured in square units, and can be measured using a net. So remember, we have that box, and if we wanted to take it apart, we could have a net that we could then fold on those lines and put it back together as a three-dimensional shape. So let's look at an example that has somewhat of an example of both. Cinema theaters created a new popcorn box in the shape of a rectangular prism. The new popcorn box has a length of 6 inches, a width of 3.5 inches, and a height of 3.5 inches, but does not include a lid. How much material is needed to create the box? So to create the box, we're just talking about the faces, right? So let's start with the front face. It is, I'm going to put front here, F for front. 6 inches across and 3.5 inches tall. So we're going to end up with 6 times 3.5. Now, we're going to also multiply that by 2, right? Because we don't just have the front, we have the front and the back. So if you multiply 6 times 3.5 and then double it, you're going to end up with 42 inches squared. That is the front and the back. Now we need to do the right and left sides. Okay, so we end up with 3.5 inches times, this would be the same as over here, right? Times 3.5 inches. And we're also going to double that because we have this side and this side, right? We have the left and the right sides, so to speak. And we end up with 24.5. Now the tricky thing, and that would be the right and left sides. Now we need to fill the top and the bottom. Here's the trick though. Remember, it doesn't have a lid. So there's actually not a top. So we could find the surface area. We could do, of course the bottom is going to be 6 inches long and then by 3.5 wide. We could do that times 2 and then take away one section, but we don't need to do that. We can just do the 6 by 3.5, which is going to give us 21. These are all inches squared. But we don't need to double that one because there's only the bottom. There's not a top. There's not a lid. So then when we add this all together, we end up with 87.5 inches squared. That is the surface area of this new popcorn box. That's how much it holds. Okay? Now, that's the outside of the box. What we want to know now is how much popcorn can we fill inside the box. So now we've already found the surface area, but now we need to find the volume. So for our volume, we're going to take length times width times height. So we're going to do 6 times 3.5 times 3.5. For the sake of time, I'm not doing these problems, but we could obviously just do them off to the side. But you end up with 73.5 inches cubed, because it's volume. So the volume of the box is 73.5 inches cubed. That's how much space, volume of popcorn this box would hold. So this is a great real-world example of two different types. So you have the same item, a popcorn box. Surface area is what you use to make the box, right? The outside faces. Volume is what goes in the box, how much can fit in the box. In this case, how much popcorn can fit in the box. Okay, we're going to look at one more example here. This one focusing on surface area. This time we don't have a visual. So it says Vincent put logs in the shape of a rectangular prism outside of his house. However, it is supposed to snow and Vincent wants to buy a cover so the logs stay dry. If the pile of logs creates a rectangular prism with these measurements, 33 centimeters long, 12 centimeters wide, and 48 centimeters high, what is the minimum amount of material needed to cover the pile of logs? They ask it that way because, of course, you could buy something huge and you wouldn't really need to know the exact fit, but we want to know what would be an exact fit. So what I'm going to do is one of my strategies for this question. So I'm actually going to draw this. So I know that this is going to be 33 centimeters long. It's going to be, that's going to be higher than that. This is not to scale, obviously. 48 centimeters high. And then as I draw this, we're going 12 centimeters wide. So now it's just a matter of finding the surface area. So I'm going to take 33 times 12 to get the top and the bottom. So since there's two of them, I'm going to take 2 times 33 times 12, which is going to give us 792. I'm going to add that to 2 times 48 times 33, which is going to be the front and the back. And if I multiply that out, I'm going to get 3,168 centimeters. And then I'm going to have 12 times 48, also doubling that because we have the right side and the left side. And that's going to give us 1,152. I have to add all of those together, and what we're going to end up with is 5,112 centimeters squared, because it is surface area. So I know I did that fairly quickly, but I wanted to show you that mainly what I'm going to do for this kind of problem is I wanted to show you the strategy, which is draw your own picture. You know it's a rectangle. You know it's 33 centimeters wide, 48 high, 33 long, 48 high, 12 centimeters wide. You can draw and label your own picture. Doesn't have to be pretty. Mine was not to scale. Mine did not look good, but I got the idea, and it helped me keep in mind or keep track of the fact that I've got a front and a back, I've got a right side and left side, and I've got a top and a bottom. So I'm going to make sure I double all those up. So, all right, I'm going to stop there. We'll do some more examples together in class and look at some more kind of things we can do with this kind of math. And so we'll talk to you very soon, face to face. Thank you for watching.